Okay, talking about the relationship now between temperature and pressure. This is Gay-Lussac's law. So when the Kelvin temperature of a gas doubles at a constant volume and the amount of gas, the pressure is also going to double. So you can see that over here, that if temperature is 200 Kelvin, the P is 1 atm, where if we change the temperature to 400 Kelvin, it will double to 2 atm. So we're going to be able to use the temperature-pressure relationship, otherwise known as Gay-Lussac's law, to determine the final temperature or the pressure when the volume and the amount of gas are constant. So let's look at this. So the pressure that is exerted by a gas is directly related to the Kelvin temperature of the gas. So P1 over T1 equals P2 over T2. And so the volume and the amount of gas are constant for this equation. So let's try to apply. So let's solve using Gay-Lussac's law for P2. So again, P1 over T1 equals P2 over T2. Rearrange it so that we can solve for P2, multiply both sides by the T2, and they cancel out. So we end up getting P2 equals P1 times T2 over T1. So let's do this with a little calculations examples. Okay. So a gas has a pressure of 2 atm at 18 degrees Celsius. What is the new pressure when the temperature is 62 degrees Celsius? Remember that volume and moles are going to remain constant. So step one, let's organize. Okay, we have our conditions 1, our conditions 2. We know that our temperature is going to increase, and so we can predict that our P is going to increase again, noting that volume and moles are going to remain constant. So let's rearrange to solve for the unknown quantity of P2. And that gives you P2 equals P1 times T2 over T1. And then we're going to substitute the values into the gas law equation and calculate. So then that gives us P2 equals 2 atm times 335 kelvins over 291 kelvins, and that gives us 2.3 atm. So let's have you try. So if we have a gas and a pressure of 645 torr at 128 degrees Celsius, what is the temperature in degrees Celsius if that pressure increases to 824 torr? Again, V and N are going to remain constant. So we are going to set this up. Conditions 1 are here, conditions 2 are here. We know that the P is going to increase, and we can predict that the temperature is going to increase. So let's substitute the numbers for the values, and we end up getting that T2 is 401 kelvins times 824 torr over 645 torr. That's going to give us 512 kelvins. When remember our relationship between Kelvin and degrees Celsius, we're going to take 512 kelvins minus 273, and that gives us 239 degrees Celsius. Great, let's try it again. So explain why water boils at a lower temperature in the mountains than at sea level. Pause me, think about it, and come back. Well, the atmospheric pressure in the mountains is less than at sea level. And so the vapor pressure of the water is going to reach the atmospheric pressure at a lower temperature. Great job, guys.